And this is the wireless local area network, and this is the most prevalent type of network today. They're everywhere. Your home, Starbucks, your office, the grocery store. If you're in the United States, Lowe's, Home Depot, shopping centers, they're everywhere.
That's Bob Liggett, an engineer and content developer for Cisco. In this episode of the Cisco Learning Network Podcast, get an introduction to the types of existing wireless networks and learn the basics of wireless topologies. Both of these concepts are important to master for the CCNA Wireless certification exam and are also frequently referred back to in Bob Liggett's other presentations. Bob recently spoke in a CCNA Wireless Training Videos webinar hosted by the Cisco Learning Network and begins by giving an overview of the three types of wireless topologies.
So we're going to be talking about wireless fundamentals today, which is a lot of fun. So let's get started. We have to start at the beginning when we start talking about wireless, and that's really in the topologies. Wireless networks are ubiquitous. It makes no difference where you go today. There's a wireless network out there of some type. We're going to begin our discussion today by covering the different types of wireless topologies. And you all are probably aware of more than one of these types, but maybe not the names. With the WPAN, or the Wireless Personal Area Network, these networks are really pretty small, 5 to 10 meters of coverage, and really are designed for personal connectivity. So think in terms of your laptop, a tablet, a smartphone, connecting to a printer or some type of device in that space, or even potentially a wireless keyboard or mouse. And we have the WLAN, and this is the wireless local area network, and this is the most prevalent type of network today. They're everywhere. Your home, Starbucks, your office, the grocery store. If you're in the United States, Lowe's, Home Depot, shopping centers, they're everywhere. And these types of networks have a coverage range of about 100 meters or 328 feet. And as we said, the WPAN was really a personal connectivity environment, and the WLAN is for handling many, just a few to hundreds of people at a time. So this is also a standard-based environment. It uses the IEEE standard 802.11 and is also referred to as Wi-Fi.
The IEEE 802.11 that Bob just referred to is a set of media access control and physical layer specifications for implementing wireless local area network computer communication in the 900 MHz and 2.4, 3.6, 5, and 60 GHz frequency bands. They are created and maintained by the Institute of Electrical and Electronics Engineers, or IEEE. The base version of this standard was released in 1997 and has since provided the basis for wireless network products using the Wi-Fi brand. 802.11 uses the 2.4 GHz ISM, or Industrial, Scientific, and Medical Radio Band, which is a radio band reserved internationally for the use of radio frequency energy for industrial, scientific, and medical purposes other than telecommunications. This ISM band operates in the United States under Part 15 of the U.S. Federal Communications Commission rules and regulations. Because of this choice of frequency band, 802.11 may occasionally suffer interference from things like microwave ovens, cordless phones, and Bluetooth devices.
And this is, as Carlos said, this is the foundation or the focus of Wi-Fund. So when we talk about the Wi-Fund curriculum for CCNA for wireless, we're really talking about the WLAN environment. The last topology is the WMAN, and this is a wireless metropolitan area network, and this falls into two different areas, and that is either a point-to-point or a point-to-multipoint, and these are outside the 100-meter driven distance. These can be a few hundred meters to a few miles, depending upon what you're trying to accomplish. And we'll talk more about these as we go through the presentation. The first WPAN we want to talk about is an ad hoc network, and this is known as an IBSS, or an independent basic service set. And before we can understand what an IBSS is, we need to know what a BSS is. And a basic service set is made up of an access point and one or more client devices. So you got the access point radio and some number of client devices. The client devices join the access point, and begin communicating, and all the client traffic goes through the AP, and this is a layer 2 network. Now, when we go and talk about an IBSS, there's a difference, and the difference is this. This is, as we said, it's the independent basic service set, but it's a peer-to-peer network, and there is no access point, so you only have client devices. The client devices still need to send, they need to share some set of common parameters. So a name and radio settings. And what will happen is that you're still going to have a station that's going to create a name for the network, and this is known as the group name. A second device that wants to join will only have to detect the group name and then adjust its radio parameters so it can create the group. And this is still an 802.11 environment, so you still have a fairly good range. And this is what is known as an ad hoc network. There are a number of caveats that you need to think about. First of all the devices have to be in the same general area so they can reach each other. And since you're talking 802.11, it's a lot larger area than you might think. But we really think of this as a WPAN. The other issue is this, and we're going to talk about this many times. It's a half duplex environment, so only one device can communicate at a time. So that in the event that two devices communicate at the same time, you end up with a collision and you also lose data. And there's a third thing that I like to bring up. There's no control over the names in these networks. So, my name is Bob. I'm going to create my network, and I'm going to call it Bob. And on the other side of the office, there's another guy. Hey, his name's Bob, and he says, hey, I'm going to call my network Bob as well. And so when the my users that want to join my network Bob go in and they see network Bob, they see two networks Bobs. They see mine and his because we're within the same area. We're in the same coverage area. And so it becomes extremely difficult to determine, which network is which because they're both named Bob. And so you end up with network instability, which can get sort of messy kind of quickly. The next one we're going to talk about is Wi-Fi Direct. Now, Wi-Fi Direct is a little bit different. This is, again, a small network in that 5 to 10 meter range, but it's really, you want to go and synchronize something. You want to synchronize your calendar. You want to take the pictures off your phone. You want to print something. You want to show something. You're sharing a file, something like that. It's really pretty straightforward. But this is a certification from the Wi-Fi Alliance. And these devices that have this certification can connect to one another without joining a traditional home, office, or hotspot network. And this can be a one-to-one connection or even a connection of a small group of devices. Again, perfect for phones, printers, gaming consoles, cameras, things of that nature. And it's very simple to connect. It can be as simple as pushing a button or tapping two near-field communications devices, and we'll talk about those in a few minutes, together, or by entering a PIN. And the Wi-Fi direct connections are protected by WPA2 security, which is really quite good. So let me give you an example of a Wi-Fi direct predefined service. Let's see, Wi-Fi Direct Send. It lets users send and receive content between one or more devices quickly and easily with minimal user interaction. And again, that's that simple push of a button or tapping together two NFC devices. And then there's another one that's sort of interesting as well, Wi-Fi Direct for DLNA, Digital Living Network Alliance.
The Digital Living Network Alliance, or DLNA, was founded by a group of consumer electronics companies led by Sony in June 2003 to develop and promote a set of interoperability guidelines for sharing digital media among multimedia devices under the auspice of a certification standard. This means that the DLNA defines standards that enable devices to share data with each other, like photos, videos, and music. The guidelines this group created incorporated several existing public standards, including the Universal Plug and Play for media management and device discovery and control, and also widely used digital media formats and wireless networking standards. DLNA primarily works with cable, satellite, and telecom service providers to provide link protection at the end of each data transfer. This enables customers to share their content on multimedia devices without running the risk of piracy. DLNA equipment is designed to work on a home network, and typically acts as a bridge between different devices that you have, so you can view a movie from your PC on your big screen TV, play a song from your smartphone on your stereo system, and send photos from your tablet to your wireless printer.
So it's another alliance that does standards for an application set that goes onto Wi-Fi Direct. And what you're doing here is you're letting devices discover each other before connecting so they can stream content on devices that support DLNA interoperability guidelines. So it's pretty cool stuff. The next one is a PicoNet. Now this is pretty cool. I like PicoNets, and you're probably using a form of a PicoNet today. Again, small range, but what we have is a network that uses Bluetooth, and it's a temporary network between 2 and 8 devices. The devices can be added and removed from the network very simply. One device is considered to be the master, and the other devices will be considered slaves. The slaves are assigned specific time frequencies or a specific time when they can make their transmissions, and that's very important because Bluetooth is a frequency hopping protocol. It has 79 frequency hopping channels, and so because of the large number of frequency hopping channels, it reduces the potential for collisions dramatically. And a good example of a PicoNet will be a Bluetooth keyboard or a Bluetooth mouse. You might even have a Bluetooth in your printer or your or something along that line, so it's in that very small range, although it can, again, go up between 5 and 10 meters. If you want to create larger PicoNets, these are known as scatternets, and a scatternet works like this. The master of one PicoNet becomes the slave of another PicoNet, so you can glue 2 PicoNets together to get a scatternet. I don't remember if there's a maximum number of stations available, but you're really talking about small types of environments here.
To hear more from Bob Liggett or to view the full webinar that this segment is from, be sure to visit the Cisco Learning Network at www.ciscolearningnetwork.com. You can also visit the link in the description, which will take you to more training videos hosted by the Cisco Learning Network that lay your foundation for CCNA Wireless. The Cisco Learning Network contains all kinds of resources to help you get started on your wireless career, including additional training videos and study groups that will allow you to connect with others trying to get started in their wireless careers. Please subscribe to the Cisco Learning Network podcast and be sure to leave us a review on iTunes if you found this helpful. Thanks for listening.